Hi Adie, I'm going to go through the worksheet with you, and I apologize for the bad video, but I just don't have any other way to do it. So atomic structure, I'm going to go through this part first. So number 1 says draw 5 protons in the nucleus of the atom. Label them with their charge. We're going to draw protons like plus signs because they're positive with a circle. So we're going to draw 5 inside the nucleus. 2, 3, 4, 5. I'm going to put little plus signs on them because they are positive. Draw 6 neutrons in the nucleus of the atom. So this is the gray part. 2, 3, 4, 5, 6. So protons and neutrons, which are just a circle, they are inside the nucleus of the atom. That's the center part. Draw 2 electrons in the first energy level and label them with their charge. That's this first line. We're going to draw 2. They are negatively charged, so we're going to put a negative or a minus sign. Now, the first shell, this first energy level here, sometimes it's called a shell, it can only hold 2 electrons. That's how many it holds. So it's just like there's just 2 in here because that's all it holds. Next, it says draw 3 electrons in the second energy level and label them with their charge. So we're going to draw 1, 2, 3. And you can put them anywhere on that line. It doesn't matter where they are. And the same is true for this line, this energy level. It doesn't matter where you put them. They just have to be on the line. So what element is represented in this particular diagram? It's boron. And you know that because the number of protons inside the nucleus is equal to the atomic number. So if you look at your periodic table, you can see that boron is number 6. And so there's 5, number 5. There's 1, 2, 3, 4, 5 protons in the nucleus, and boron on the periodic table is number 5, okay? Let's take a look at this is oxygen. This is a box from the periodic table. The 8 is called the atomic number. Usually the atomic number is on the top of the box. That's the atomic number. The O here is the atomic symbol. That is the letter or the letters that represent the element. Oxygen, that's the name of the element. And then the number underneath that usually has a decimal point after it, that's the atomic mass. That's kind of like weight. It's usually the same as weight unless we're talking about other planets. And we usually round this number to the nearest whole number. So 15.9 would round up to 16. So you would usually round that to the nearest whole number. So the atomic number, this number at the top, represents the number of protons in an atom or the number of electrons. So protons are positive and electrons are negative. And because the atom wants to be balanced or wants to be equal, you have to have the same number of protons as you do electrons. So like with the boron atom up here, we have 1, 2, 3, 4, 5 protons, and we have 1, 2, 3, 4, 5 electrons. So that has to be equal. Now, the neutrons don't have to be equal. Sometimes they are, but they don't have to be. Down here, what does atomic mass represent? Remember, that's this big number at the bottom, and it represents the number of protons plus the number of neutrons. So really, it's what is inside the nucleus. So like for boron, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the atomic mass of boron would equal 11, okay? So let's look down here. Number 9 says, how do you figure out the number of protons or electrons in an atom? Well, it's the atomic number. The number on the top is the number of protons or electrons. So oxygen has 8 protons and it has 8 electrons. And we know that because the atomic number is 8. The next question says, how would you figure out the number of neutrons in an atom? So neutrons, now they're inside the nucleus. So if we take the atomic mass, now you've got to round it first. If we take the atomic mass and subtract the number of protons, that will tell us the number of neutrons. Because if you think of it this way, the atomic mass, this number, after you round it, is everything in the nucleus. So if there's 16 things in the nucleus and 8 of them are protons, then there have to be 8 neutrons because 8 plus 8 is 16. So oxygen has 8 protons and 8 electrons because of this number, and it has 8 neutrons because 16 minus 8 is 8. Now, if you look down here at the chart, I'm going to grab a highlighter. There are some parts of this chart that are the same. So the atomic number, so I'm going to go ahead and do this. Sorry, I'm doing this with one hand here. The atomic number and the number of protons and the number of electrons are the same. So we're going to just highlight this, okay? So if there are 3 is the atomic number of lithium, then it's got to have 3 protons, and it has to have 3 electrons. And to find the atomic mass, we have to subtract, we have the atomic mass. To find the number of neutrons, we need to subtract 7, which is the atomic mass, minus 3, because we know there are 3 protons, and 7 minus 3 is 4. So there have to be 4 neutrons, because remember, the nucleus of the atom is, the atomic mass is equal to what's inside the nucleus. We know there's 3 protons, and because this is 7, there's got to be 4 neutrons, because 3 plus 4 is 7. Next up, we have, I think that's phosphorus, atomic number 15. So we know there are 15 protons. We know there are 15 electrons. And now to find the number of neutrons, you have to subtract 31 minus 15 is 16. So there's got to be 16 neutrons. All right, let's do the next one. This is chlorine. We don't have an atomic number, but we know there are 17 protons. So the atomic number has got to be 17. And the number of electrons has to be 17. To find the number of neutrons, 35 minus 17 is 18. So 18 neutrons. Let's do one more. The atomic number of nickel is 28. So we know there's 28 protons and there's 28 electrons. Now, we know the number of neutrons. So remember, the protons and neutrons are together inside the nucleus. So to find the atomic mass, we just have to add these together. So 28 plus 31 is 59. Okay, go ahead and do the rest of these, and hopefully I will see you soon.